Hello everyone, I am Vasoya and I am mathematics educator from the Gajera International School, and today I am deliver lecture on grade 12 mathematics, first topic relation and function. Okay, and in our day to day life we use the word relations. For example, he is my brother, she is my sister, she is my teacher. So look at this example and we can observe that we must need two things to develop the relations. Brother, so there are two persons. Okay, so we must know two things for the develop the relations. Okay, so keep in mind these things. And in mathematics, relation is what? A relation R in a set A is what? Subset of A cross A. Suppose I consider a set A 1 comma 2, and we earlier classes we can find a Cartesian product of two sets. So find out A cross A 1 comma 2 cross 1 comma 2 Cartesian product of set A. Fix the set element 1. So 1 comma 1, 1 comma 2 and 2 comma 1 and 2 comma 2. That means element of 1, 2 can related with itself 1 comma 2, and this is the total possible ways. And now see the definition. Any subset of A cross A is called relation. Suppose I consider any set, say R is equal to 1 2 and 2 1. So it is a subset of what? A cross A, and by definition this is what? Relations on set A. That means we can write 1 comma 2 belongs to R, and also we can write 1 is related to 2. Okay. Now there are various types of relations. In set theory we already studied the 5 is subset of any set, and look at the definition. Any subset of A cross A is what? Relation. So we can write 5 is a subset of A cross A, and also write A cross A is a subset or equal to A cross A. So by default these two are relations by the definition, and this set 5 is called what? Empty set, and that's why it is called empty relation on A. And this is the biggest subset of what? A cross A. Okay, and biggest things is called what? In set theory, universal set is the biggest set, so that's why it is called what? Universal relation on given set A. Okay, there are two particular types of relations. Okay, and now one question is there. So there are how many total relations? How many total relations? So first of all, see the relations definition. So any subset of A cross A. So for this example, A cross A has how many elements? 1, 2, 3 and 4. So A cross A has 4 elements. Okay, and in set theory we already studied the total number of subsets. So total number of subsets is what? What is the formula? Is equal to 2 power n, and n is what? Number of elements in the given set. Here there are 4 elements in this set A cross A. So total number of relations on given set is what? Set A is 2 raised to 4. Okay, 2 raised to 4. There are total number of relations on given set A. Now generalize this example. For example, set A has n elements, 1, 2 up to n, and A cross A has how many elements? N of A cross A. We know the results, n of A into n of A, and n of A has how many elements? And n into n, and that is equal to n square. Okay, so total number of relations on a set A having n elements is what? Is equal to 2 raised to what? N of A cross A equal to what? N of A into n of A, and therefore 2 raised to n into n, and it is equal to 2 raised to n square. This is the total number of relations having n elements of set A is what 2 raised to n square. And if your set is different, for example, if your set A and B, and we find out A cross B, and relation is what? Subset of A cross B. And if set A has m elements and set B has n elements, then A cross B has how many elements? N of A cross B is what? Mn elements, and therefore total number of relations on set A to set B is what? Total number of relations equal to 2 raised to mn. If your set is different, we see the types of relation, empty relation and universal relation. Now let's some examples of empty relation and universal relations. Suppose I consider a set A, set of students in boys school, and consider a relation R on that set A, AB, where A is a sister of B. So can we say that in boys school some students is a sister of other students? So there are all the boys, so there is no female. Okay, so we cannot say any students is a sister of other students. Okay, so there are no elements A and B does not belongs to R. Why? Because A and B both are what? Boys. So we cannot say A is a brother of B. So there is no single elements in these relations. So R is what? Empty set, and that's why it is called empty relations. Okay, this is the example of empty relation. And now consider another set. For example, set A is equal to 1, 2, 3, 4, 5 and 6. Okay, and consider as relations R on that set A, AB, where mod of A minus B is greater than or equal to 0. Okay, so look at this set 1, 2, 3, 4, 5 and 6. Now there are all the natural numbers, and now take any two elements and find out the modulus of that two elements. We get always, and we know that mod of any number is always greater than or equal to 0. Okay, that means first remember relation is what? Subset of what? A cross A. So there are all the order pair possible, all the order pairs, because any elements of this set is related to all the elements of set A, and that's why it is what? R is what? R equal to A cross A, because all the elements, each elements are related to all the elements of set A. Okay, and that's why relation R is what? A cross A, and it is called what? Universal relation. Okay, so this is two types of particular types of relations. Now we discuss types of relations. Relation R in a set A is called reflexive if A comma A belongs to relation R for all elements of set A. Given set A, for all the elements of A comma A belongs to R, then we said that that relation is what? Reflexive on given set. Okay, and second one is symmetric relations. Okay, a given relation is called symmetric if A comma B belongs to R implies B comma A belongs to R, where A and B belongs to set A. If for any order pair AB belongs to R, then it must be B comma A belongs to R, then it is said to be what? Symmetric relations on given set. Symmetry, you see the for the reflexive, stand up from the front of mirror, then you see the image of yourself. Okay, so you can relate reflections and reflexive A comma A belongs to R, and this one is what? Symmetry. And in lower standard you draw the drawing of symmetric. Suppose there are this thing and this is symmetry, so there are this one, that means symmetric are there. Okay, like that you can correlate. Okay, and now third one is what? Transitive relations. Relation R on set A is called transitive if suppose there are two order pair AB and P comma C belongs to R. Consider two order pair AB and BC belongs to R. Then what happens? Then if A comma C belongs to R, for A, B and C belongs to given set A. If AB belongs to R and BC belongs to R, implies AC belongs to R. For example, suppose you have to go from Surat to Ahmedabad, Surat to Ahmedabad, okay, but first of all you go to Surat to Baroda and Baroda to Ahmedabad, then we can say that we are going to from Surat to Baroda. That means via things, okay. If A is related to B and B is related to C, then A is related to C, then we say that relation R is what? Transitive relations, okay. There are types of relations: reflexive, symmetric and transitive, okay. Keep in mind this definition of all the three types of relations: reflexive, symmetric and transitive, okay. Now next types of relation is what? Equivalence relation. When we say that relation R is called equivalence relations, if your given relation is reflexive, symmetric and transitive, if any relation satisfies all these three definitions, that means it is reflexive, symmetric and transitive, then we can say that that relation is what? Equivalence relations on given set, okay. Now we discuss one example of relations, and we check the reflexive, symmetric and transitivity. Consider a set A is equal to 1, 2, 3 up to 14 and relation on that set xy where y equal to 3x, okay. And we have to check the given relation is reflexive, symmetric and transitive. So now for the reflexivity, what is the definition? Remember the definition: reflexive for all the elements of set A related to itself. So check whether, and we write by two ways: particular way and general way. Keep in mind, in mathematics, if you want to prove any statement in mathematics, then you must give the general proof of the statement, and if you want to any statement make false, then give one particular example. For these examples, this statement does not hold, then it is enough things. So we use that two things here, okay. So now reflexive, first of all we list the all the elements of relation R, okay. So R is what? First list the all the elements of R. What is xy? Elements of set A, and set A has 1, 2, 3 up to 40. So now put the value of x equal to 1 here, okay, 1. So y equal to 3 into 1, so we get 3. So 1 is related to 3. Now put x equal to 2, we get what? 2 into 3, that is what? 6. So 2 comma 6. Now put x equal to 3, so 3 into 3, 9. So 3 comma 9. Now put x equal to 4, so it is what? 4 comma 12, 4 3s are 12, and put x equal to 5. So we get 5 into 3 is equal to 15. So y equal to 15. But keep in mind, this set is what? Subset of A cross A, and set A does not have element 15. So 5 comma 15 are not in relation, okay. So there are the possible elements of R, okay. And now particular things for the reflexivity. Here 1 belongs to A, but see the order pair 1 comma 1 are in R or not? 1 comma 1 lies in R or not? So there are no 1 1 order pair in relations. So 1 comma 1 does not belongs to R, and therefore what? R is not reflexive, okay. And this is what? Particular things. We give the particular example to check the reflexivity. Now what is the general thing? See the relation x and y related with this relation y equal to 3x, okay. So for same element we cannot write x equal to 3x. This is not holds for the all the elements of set 1 to 14, okay. This is general way. Here we put x, that means any element of A, okay. x is not equal to 3x, and that's why R is not reflexive. Okay. And now second thing is what? Symmetric. Now what is the definition of symmetric? If AB belongs to R, then B comma A belongs to R, then we say that given relation is what? Symmetric. Okay. So first of all, I prove by the particular things. Consider element 2 comma 6. Look at here, 2 comma 6 belongs to R, but 6 comma 2 doesn't belongs to R. There are 2 comma 6 order pair in relation R, but 6 comma 2 is not there. So R is not symmetric on given set A. Okay, and this is particular things, we give the example. Now what is the general thing? Let x comma y belongs to R, this order pair in relation, and that's why that two elements related by this relation, y equal to 3x. So implies that what? Divide by 3 both the sides, we get y by 3 is equal to x, and therefore x equal to y by 3, and it is not equal to what? 3y. Okay, x equal to y by 3 is not equal to 3y for all the elements of set A, and therefore what? Y comma x does not belongs to R. This is the general thing. Okay, and this is particular example for 2 comma 6. You can write any one of the proof. Okay, so given relation is not symmetric. And now third thing is what? Third one is transitivity. Now check whether particular example. Okay, suppose I think consider two order pair, and like what? 1 3 and 3 9, that means second element of first order pair and first element of second order pair are same. So consider 1 comma 3 and 3 comma 9 belongs to R. That means there is 1 is related to 3 and 3 is related to 9. But now is there a order pair 1 comma 9 in relation? So it is not there. So 1 comma 9 does not belongs to R. That means 1 is related to 3 and 3 is related to 9, but 1 does not related to 9. That means transitivity definition does not holds for this particular two order pair. Okay, so therefore R is not transitive. Okay, and general thing is what? For the transitivity, consider two order pair, any two order pair in the relations. So let x comma y and y comma z belongs to R. These two order pair in relations are, that means x is related to y with this relation. So that gives what? Y is equal to 3x, and from this order pair we get what? Y equal to 3x if xy belongs to R, and here what? Yz belongs to R, and that's why what? Z is equal to 3 into y. Okay, so now put the value of y equal to 3x here. So we get 3 into y is what? 3x, and that is equal to 3 into 3, 9x. Okay, so we get the relation in x and between x and z. But if y equal to 3x, then xy belongs to R, but here z equal to 9x and it is not equal to 3x. Okay, and that's why what? X and z does not related. That means order pair x comma z does not belongs to R, and this is the general thing for the transitivity. Okay, so here x and y and z both are in relation, but x and z does not belongs to R. Okay, and therefore R is what? R is not transitive relations. Okay, not transitive on R. Okay, so I hope all these point and all these relations topics you can understand very well, I hope. Okay, and thank you.